Okay, Math 90, this is section 2.1b in Hawks, and we're going to be talking about variables, constants, and terms. So it might be review for you, might not, might not be. So let's start with the variable. What is a variable? So we use variables a lot in math. It's really just a letter that represents a number. And we can use any letter we like. A lot of times in math, they use X and Y, but you can use any letter. You'll see a lot of different letters. X, Y, A, B, usually we use X and Y a lot, but you can use any letter. So variable is just a letter. Sometimes we know what the variable means, sometimes we don't know the value of it. So sometimes we're looking for it, sometimes they will give it to us. So next up is constant. Separate this. And a constant is just something that always stays constant, like a number. So we could say 5 is a constant. It's always something that's going to stay 5. 10 is a constant. 11 is a constant. 100 is a constant. It's just something that always stays that same value. So it's like it is a number. Okay. So I've got variable and constant. Now I'm going to put these two together and make up a term. So a term is a group of constants and or variables, and we could throw some exponents in there. We don't have to, but if you see one in there, that's could be part of the term as well. Okay, so it's going to have could have a constant with a variable, like you could say 3x is a term. It's got a constant and a variable. You could say 3xy is a term. It's got two variables and a constant. We could throw in a exponent. So let's say 5x squared is a term. It's got a constant, a variable with an exponent. We could say 6a squared b squared is a term. Let's throw a negative in there. We could say negative 12, that's my z, is a term. That's a variable and a constant. Or we could say negative 4z squared is a term. So you're kind of getting what the gist of a term is. It's got constants, variable, or it could just have a constant. Sorry, we could say 10 is a term. or just a variable. C is a term. So it could be a constant by itself or a variable by itself. So when we talk about terms, we talk about unlike terms and like terms. So unlike terms, let's get that straight. Examples of these, or examples of unlike terms, would be me underline 5x and 7y. We don't care about the 5 and the 7, but the variables need to match up. And here x and y do not match up, so they're unlike. 10ab and 2bc. These are unlike terms because AB does not match up with BC. They have to match up perfectly. So AB and BC don't match up. Those are unlike. Let's throw some exponents in there. Let's say 10x and 4x squared. Okay, these are unlike because x does not match up to x squared. So they have to match up perfectly. Match up perfectly. Let me do one more with the squared. Let's say 16x squared y and 15x squared y squared. Okay, you might think, these match up because they both have x squareds. Well, the x squareds do match up, but look at, you've got a y and a y squared, and these put the kibosh on it. So these are unlike terms. They do not match up. And if they are unlike, we can't really do anything with them. So we leave them as is and we move on. We can't do anything with them. So those are unlike terms. Let's talk about like terms. Those we are going to be working with a lot, not so much the unlike terms. So like terms, their variables and exponents match up perfectly. So here's some examples of like terms, which I said we're going to be working with a lot. So 6xy and 7xy, perfect match. Perfect match. We don't care about the numbers. We just want our variables, our exponents to match up. Okay. 5bc and 2bc. They both have a BC. Match up perfectly. They're like terms. 7, that's my 7. X squared y and 11 x squared y. They both have an x squared and a y. They match up perfectly. They're like terms. Okay, 3a squared b squared c and 13a squared b squared c and 5a squared b squared c. These three, whoops, not on the 5, just on the a squared b squared c. Those match up perfectly because all three have an a squared b squared c. And like I said, I'm sorry I underlined the 5. We don't care about the number part, we just care about the variable and exponent part. If they match up perfectly, they are like terms. If they don't, they're unlike. So I'm going to stop there, and I will finish up this section in the next video.